All right. One thing that we started working on, and it had to do with that worksheet where we had a bunch of those solutions, which is totally fine at that point. But let's make clarification. Hang on. So let's talk about the word, two different words. The word and the word or. If I said, my friend and I went to the store, who went to the store?
My friend and you.
Yeah, there were, how many of us were, that went to the store?
2.
There were 2. If my mom or my dad will pick me up from school, who will pick me up?
Your mom or your dad.
So one or the other. It doesn't have to be both, right? That makes sense when I say that? So let's get to when we were talking about, remember we had this number line and it got goofy because when we shaded it, it kind of went right through it. Remember that?
Yeah.
And we said there's no solution, so we're going to start backing away from that and undoing it. So let's talk about a problem that is and, okay? So let's say we've already gone through the whole process and solved it, and it comes down to this. So this is 2 problems, agreed? So if I graph this one, this is the same thing as me doing this, which is the same thing as me doing this. Agreed? Anyone stuck? And then the other problem is this, which I don't really have to flip over, correct? So as far as a line goes, we would have, say, 0 way down here. SD, I'll move the 0 down that way because I'm going to want to use this way. Is that okay? Okay. And a 4 and an 8. Does everyone feel okay with that as a number line? And so right now I have a solid dot here. I have a solid dot here. And that just basically means I'm going to shade in between the 2. And I could say that this is square bracket 4, square bracket 8. And that's the solution how we want it to be. Right? Mm-hmm.
So if there isn't,
hang on, do you agree with me up there?
Yes.
Okay, so I know what your question is going to be, and we're going to answer it here in a second. Cool? All right. So let's just modify this question a little bit, just so we can get it to say what we want it to say. So I'm going to change this question okay? So let's pretend this is now the question we want to deal with. Still with me?
Yeah.
So I'm going to just go down a smidge. So this, I can break into this, which I flip over, which gives me this. Agree?
Yeah.
And then this is still that way. And as far as the number line, it's going to look very similar to what I just did. But let's figure this out. What is this one doing?
Infinity to 4.
Yeah, negative infinity to 4. So that's kind of going this way, right?
Yeah.
Agree?
Yeah.
What is this one doing?
Going negative infinity. So that's no solution.
All right. So now, let's think about this. My graph is going that way. What's a number? So here's basically my range that we had dealt with above. So what's a number that's definitely to the left of both those numbers? That
-2.
2, 0, -1, all kinds of those, right? So let's just think about this. If we plug 2 in, is 2 less than 4?
Yes.
Is 2 less than 8?
Yes.
Okay, so 2 worked. Let's plug 0 in. Is 0 less than 4?
Yes.
Is 0 less than 8?
Yes.
0 worked. So, and this is a and problem, correct? But then let's take a number, say, right here. Yeah, 5 or 6 or something. Does everyone agree that there's somewhere in between? So let's take this, plug it in. In order for this to work on our graphed shaded region, that number has to work in this problem and this problem. It has to work in both. So here's my 2 problems it has to work in. So let's plug 6 in. 6 is less than 4.
No.
So we get a no vote. 6 is less than 8.
Yes.
Did it work with both?
No.
No. Okay? 6 did not work in this and this. It only worked in one of them. So which one did it work in? So it worked here, didn't it?
No.
No. We have a no and a yes, right?
Mhm.
Was it a no here?
Yes.
Was it a yes here for this number 6? So I'm going to start here. I'm going to start here because anything this way is not going to work. And this is what my line looks like right now. Okay, so let me pause before you get there. Wait, I don't get it. Okay, if I pick any numbers that fall in this region right here, it won't work on both of them. What happens if I pick any numbers over this way? Doesn't work on either of them. So none of them work, only one of them works. Now they both work. And it's and. And means they both have to work. They both have to be true. Okay, they both have to give us a yes.
No solution.
No, here's the solution. Negative infinity to 4. Why does that work that way? No, it does. Look, hang on. Did it work when I picked the number here? And then I picked 0 and it worked. If I picked negative 2, it worked. If I picked negative 10, it works. Okay, so from here, going this way, it works on both of these, here and here.
So the only way would be no solution.
Well, let me try one more time. I'm going to just pick 0. 0 is definitely to the left, and I don't think I'm going to get lucky just picking 0, and it'll happen to work on both. It's not going to be the arbitrary only number. Ready? 0 is less than 4, yes or no? 0 is less than 8, yes or no? Let's pick negative 10. Negative 10 less than 4.
No, I understand.
No, so,
Yellow highlighted.
but only one of them worked here.
Yeah, so then why did you do like the infinity and 4?
Where does our graph work for both? Well, yeah, it's over here.
Oh,
This-
I see.
So this, someone's catch the lights for me, please, because
I got it.
thanks, Steve. So think about this. Think about this. This region starting right here and going this way, not really magic pen, going that way, is where this works on this one and on this one. So again, the word and means both, correct? So where does my number line start working for both? Right here. So from negative infinity to 4, if I pick any number that's smaller than 4, all the way up to 4, this is a square bracket, it works here and it works here. Okay? Yeah.
Wait, so if this is an and problem, it has to work on both, right?
So we need to figure out where does it work for both.
So doesn't it have to be in the range of both those numbers?
No, because here it only works on one of them. It doesn't work on one and the other. So we have to figure out where does our graph work on both. Thank you. Okay? Yeah.
So then what happens to the 8?
Well, this yellow region here. Whoa.
Whoa.
Sorry.
Magic.
Oh, get off the magic pen.
Use the creative pen.
No, I'm just going back to regular. Where it works here is only on one of our parts of the problem. I want it to work on one part and the other part.
And then
So from here to this way, forever and ever and ever, it will work on both of our problems.
but then why don't you have like the 8 and the implementation?
The 8 doesn't work on both. And means both.
Yeah, so then
My
4
friend and I went to the store, so both of you went to the store.
I know. 4 and 8 went to the store together.
Right. If I plug 8 in, look what happens when I plug 8 in. It works here. It does not work here.
But what if, like,
How many problems is this?
2?
2. Okay. There's 2 problems. Agreed. I'm trying to get the disconnect. You have two problems. Yes? So it has to work on both those problems.
Yeah.
Both.
Why wouldn't you put it in that?
What?
Yeah, exactly. You have to use both of them.
Right. Here's one problem. Here's the other problem.
Yeah, but they're not taking interval notation. Why aren't you using both?
Because it's right. Because it doesn't work here.
Yeah, but how are you not allowed to?
Okay. Okay. So two problems. Problem number one. Problem number two.
Yes.
It has to be true both.
Exactly.
Okay. So you've answered my question, right?
Yeah, so it has to be both in interval notation.
No. Just this one. It Look, do you agree that these numbers don't work on both?
Yes.
Okay, so where are you arguing me on this?
No, because those.
See, I think they're saying, why aren't you using like both of the numbers in there?
How are you allowed to put four? So you're leaving
Because you're only using one and not
Why are you allowed to put 8 in? Why are you allowed to?
Because 8 doesn't work on both.
No, but if you use like.
But it doesn't work on both.
Yeah,
Oh, I get it.
But you just said, you have told me, I have two problems. Right? So you're with me on that. This part, so 5, 6, 7, 8, works on only one of the problems.
I know, but like, what if you're using like 3? Because then you could do that for 3.
Oh, 3 works on both,
Exactly.
and 2 works on both, and 1 works on both, and 0 works on both, and negative
Okay,
1
I
works.
That's exactly what he's saying.
See?
Alec.
So look at the graph.
Yeah, what happens? Why don't you have to include it? What happens to the 8?
Okay, I have two problems.
Oh my god.
I have to get a true statement on both problems. What part of that are you not connecting with? I don't know any other language to convey it to you in. I have two problems. Problem 1 this hand, problem 2 this hand. You with me? If this gives me false, I ignore it.
So then you just like scratch it.
What does ignore mean?
You're like.
Okay, is anyone else, or is it just the Tempe twins over here?
I think it's just they always like have the same exact thought process. It's crazy.
So, the region that our problem doesn't work is in between here. It does not work. It really doesn't work out here at all. So, out here is false, false, and then I get to here, it's false, true. And then over here, I get true, true forever, no matter what number I plug in. For my how many problems?
2.
So, this problem and this problem work here. Yes? Notice where it says true, true. Where it says false, true, one of the problems does not work.
Which is 4. 8. No.
No. So right here, one of the problems doesn't work. I don't care which one doesn't work. I just want you to agree that one of them doesn't work.
Yeah.
Both of them definitely don't work over here.
I'm just confused why you don't put it in notation by 4, 8.
I did. Because 8 is not part of the solution. This is the only portion of the solution that works.
Because if it went up to 8, then
There's no other part that's going to work. This is the only part that gives me true, true. There's no other part. Not 5, not 6, not 7, and 8.
you can't see the negative
Or-
anymore.
Abby, you said 3 words. That's exactly what he's saying. Everything past 4 works.
I know, but why don't you include 8 in this?
Oh
my
Because 8 work on both.
Nothing
not
past
work.
4 words. 5, 6, 7,
Everything
8.
up to 4 works.
So why is
Everything
that
up
not
to 4 works.
So 5, 6, 7, and 8
Don't work.
are this region here, yes?
We know they don't work.
They don't work, so we don't include them.
The highest number is on the left or on the right. It can go to 4 is the highest.
All right,
number.
let's try another one. All right. All right, this is another one.
Let's use the numbers one.
Okay? This is an and problem because it's all put together. Agree? So both parts have to be true and true. So hang on. So I'm going to put this. This is my first problem. Whoops. I the wrong way, sorry. And then here's my second problem. Everyone is with us, yes?
Yes.
Anyone stuck on this?
Yes.
Hang on, Ron. I know you're going to be like 3 steps ahead of me, and you're awesome. Everyone agrees there's 2 problems. I have a blue problem up there that I broke up the big blue problem into, and a red problem. Okay, so if this is an and problem, which it has to be because it's put together, both parts have to be true. So let's put this on a number line and let's figure out what this means. So I have -3, -2, -1, 0. Still with me? 1, 2, 3, and 4. Does everyone feel comfortable with that number line?
Yes.
So this, how do I represent this on this number line? Open circle going which way?
Left.
Going left. You with me? What about this one? How would I represent this? I don't know which one's working, which don't work. Close circle and going left as well.
This is no solution.
Okay? Everyone agree?
That's a solution.
Okay? All right. So let's figure out where they both work. Okay? What happens if I plug 5 or 6 in? Neither works. I get no. Agree? So anything this way is not even thought about. So 4, 3, 2, 1, 0, 1, negative,
No, yes.
-1, -2. Okay? So if I pick up, let's try this one. Let's plug 0 in. 0 is less than -3.
No, false.
Uh-oh. So that gave me a false. And okay, let's try this one. 0 is less than or equal to 4. True. Okay, yes or no?
Yes.
Okay. So what region appears to not work on both of them?
Above 4.
From 4 all the way down to 0, even further down?
Negative.
Now, what happens if I plug -3 in?
Yes.
-3 is less than -3.
No.
But what about -3.1? Why is -3.1 a little bit to the left of -3?
Yes.
So -3.1, is that less than -3?
Yes.
True. Is -3.1 less than -4?
Yes.
So this is the region I want. So if I graph this, it's -infinity all the way up to what number? -3. Do we include -3?
No.
No.
It's parentheses.
Done.
Wait,
They're just making it super confusing.
Yeah, I know. It's like, let's make
I have
it more
one. I
confusing.
just-
Talk to me, Rob. Thanks for your patience.
Okay, so for an and problem, they just have to overlap somewhere, right?
Yes.
Okay.
Love
Guys, alright, guys.
It could be.
Okay.
I'll show you. I'll do an and here in a second. That's not going to work, and that's just going to.
No.
Yes, SD.
Why is it not no solution if they have to be and they both have to work? Then why is only
Okay.
one working? Why is it not no solution?
Okay.
I don't get it.
Okay, and I agree with you. Okay, is there a part of this graph that I get true and true by what I just did? You agree with me? Okay, so that means it has to be part of the solution at that point. Is there a part of this graph that we get a true and a false? Yes. That can't work because it's and. Because both parts have to work.
So would that be an or problem?
Here's the nice thing. Or problems always start out with the word or as part of the problem. That's the beautiful thing. And sometimes might have the word and or put together. Okay? Esty, do you agree that part of this solution up there is false, false? So we have false, 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 true, true, true. Good? The only part that we worry about is the true, true. Because that works on this portion and this portion. She's almost there.
So it works from here down, but not from
You did only.
It works on the purple portion we have graphed up there.
So you only did the left.
Only did the far left side.
But what if it's like a reverse problem? So
Oh, okay, the right side work.
Okay, so let's do this. Let's say we have a problem that looks like this. Okay, you with me? What kind of problem do you think this should be? This is an and problem. It's all put together. If it was an or problem, the word or would be in there. Agree? All right, so let's take a look. I'm going to take this portion
Flip it.
and I'm going to flip it over. Still with me? And then my other problem is this problem, which is this. Agree? So let's put this on a number line. So I have -2, -1, 0, 1, 2, 3, 4, 5. Okay? So -2, solid dot, going this way. Okay? This is an open dot going this way.
No solution.
It is a no solution, but this is why it's not a solution. All right. Because they're not touching exactly right.
Yes, that's true.
Oh gosh, now we just gotta get out
Maybe
of
don't you fill in the middle?
Okay, so we all agree this. We all agree this, yes? That means both parts have to be true.
Yep.
So if I pick, say, -10, which is over here, -10 is less than or equal to -2. That's true. If I plug -10 in here, I get false. So does anything in the purple work?
No.
No. Let's pick in the middle. 0. 0 is less than or equal to -2.
No.
0 is greater than 5.
No.
So nothing in between here is going to work. Still with me? All right, so let's pick a number to the right of 5. Let's pick 10. I don't know. 10 is less than or equal to -2.
No.
10 is greater than 5.
Yes.
Is there a true section up here?
No.
Does anybody see a true section?
No.
Is there a number that's like way beyond 10 that might work?
Infinity.
So let's pick 100 trillion. 100 trillion doesn't work on the red. It works on the blue.
And then the 100 till I know it's on the red and not the blue.
There, giddy up. So this has no solution. How do you write no solution? You could put it in square brackets. Do that. That means no solution as well.
Okay, so wait.
Yo.
No, I have no question on this. Okay, so for an SD, or not SD, for an OR problem. For an OR problem, okay, so for an OR problem, how would you represent it on,
We're going to get there. We're there. Okay.
Can you go back to one of those weird problems with the solution that aren't really? Isn't it because if this is like the ones with the actual shaded middle with like all
That's
so
a
not no
solution.
solution, but half solution.
Only half the solution. Like
If
that
it's
one?
shaded in between, that means it's a
Okay.
Because why do you shade that one but you don't shade?
Okay. So my test, I am test shading what the problem says. So that's why I have the green shaded and the purple shaded. Still with me?
Yep.
Now, just because I test shaded does not mean that everything's going to work. So if it's an and problem, I have to find where we have the true or the yes to answer our questions. Okay? I can't have true false or yes no or no yes or some order. Both parts have to work. Okay? So now the next part we have is or.
yay.
Okay? The nice thing about having an or problem is the word or is in the problem. Okay? So, in order for your solution to work, you guys ready? This definitely works. This works, and this works.
How?
Because my mom or my dad will pick me up today. So if I was the teacher who was on, parent pickup patrol, and I had a note that said Ram's mom or Ram's dad will pick him up today, and I get over to the car and it happens to be Rom's mom, does that satisfy part of the equation?
Yes.
Or yes.
No, I thought you were writing false. That's the reason I said.
I don't want false. Now, if Rom's Aunt Judy, okay, he has an Aunt Judy, sweet. Rom's Aunt Judy is, hi, I'm Rom's Aunt Judy, and I look at my card and it says Rom's mom or Rom's dad, not Rom's Aunt Judy.
What the heck?
Guess what? Rom doesn't get into the car to go home with Aunt Judy.
What if she's got
Out of the safety of the kid.
But what if she has candy?
Then I'll take it and
What if she drives a white van?
push it. So,
They said I could.
so a lot of times for the security of a kid, because your safety first. Yes, ma'am.
I don't get why choo-choo is up there.
Okay, this or that. Did this or that work? So let me go back to Rom's example.
My example.
Ready? If Rom's mom and dad were both in the car, can I still put him in there?
Yes.
Okay, that's
No,
fine.
no, you can't. Yes, you can.
Yeah, you can.
Oh,
Yeah,
make
so
this dad
simple.
walk.
Is or the
Oh
same
my
thing?
God.
Is one of those going to be true?
Oh,
That's where you're looking.
I should jump out of
Okay.
the
So in or event, you're looking for one of those to work. Okay, one or the other to work. Okay, so let's do this.
Wait, what happens to false fall?
Nothing.
False, not going to work. It's
It's
it's not part of the solution. It's not part of the solution. Okay, we know this is an OR problem. How do I know it's an OR problem? The word OR is in there. Good?
good.
Okay, so as far as the number line goes, -6, -5, -4, -3, -2, -1, 0, 1, 2, 3, 4, and 5. Everyone still comfortable?
Yes, sir.
Okay. Ready?
Yes.
What is this? It's closed dot going which way?
Left.
Everyone still with me?
Yep.
That's going to the right.
Open dot right?
Open dot left.
Right.
To the right.
No.
I don't know my
No,
Okay.
that one's a
Still with me? Still with me? Still with me?
Yes.
Okay. So this is like one we've been working on. So if I pick, say, -10, which is over this way, -10 is less than -6. True. Agree? Or -10 is greater than 5. This is part of the solution. Why is that? One part was true.
Satisfied.
Okay, let's pick 0. Let's pick 0. 0 is less than -6.
No.
False. 0 is greater than 5.
No.
Wait, but
This is not part of the solution. Why is that?
Because it doesn't satisfy any.
None of this is. It's Aunt Judy picking them up. Okay?
God damn.
Then if I were to pick, say, 10 over here, 10 is less than -6. That's false. But 10 is greater than 5 is true. So our solution here is going to go from -infinity to -6. Okay? Or
Negative or infinity to 5.
it's not a no solution.
I
Okay?
Because it's an OR problem, and it can do either or.
Okay.
Wait, hold on.
Right. One part or the other. They both can work, or one part or the other. Okay. So let me ask you all this. This might help you. Okay. Let's talk about light switches in your house. You with me in this story?
Alright, yeah.
Okay. Now sometimes you have a single light switch that controls the lights that turn on in a particular room, or a lamp, or a fan, or something. Yes?
Yes.
Everyone agree?
Yes.
Now, in my house, right next to the master bedroom, I have a light switch that turns on the hall light. Right next to my daughter's rooms, there's that same light switch that turns on those hall lights. And also right down at the bottom of the stairs is another switch that you turn on, which will turn on those same lights. So there's 3 switches that control the hall lights. Are you with me?
Yes.
Yes, we are.
Okay, So this is the operation that's basically taking place. You know, as far as the light switch goes, the up position's on, the down position's off. Do you agree?
Yeah.
I mean, yes, you could flip it over, but for the most part, they're supposed to be down is off, up is on. So what is my circuit looking for? It's looking for one of those to be flipped up to work. If all of them are down, the lights aren't on. If any one of them comes up, it goes on. Okay? So this or this or this. Now, other types of scenario that might work is if you just have two light switches for the same thing. So like maybe I have a light switch over here that turns my lights on and off, and a light switch over there. Okay? This or that have to be in the on position for these lights to turn on. Okay? So let's create this problem like this. Again, we're going to use or. -6, -5, -4, -3, -2, -1, 0, 1, 2, 3, 4, and 5. Okay? Okay, so what does this graph look like? Open dot, going, right? What does this one look like?
Open dot.
Everyone with me?
Yeah, that's another solution.
Okay, hang on. So if we were to have graphed this, this appears it's doing this. Agree?
Yes.
Okay, hang on. So let's just pick something way out here. Let's pick -10. -10 is over this way. Agree?
Yeah.
-10 greater than or equal to -6.
No.
-10 greater than 5.
No.
So everyone feel comfortable that from here over isn't going to work.
For all the or ones, no solution.
Okay? Okay, now let's pick like 0. Shh. Pick 0. That's the in-betweenness, right? 0 greater than -6. True. 0 greater than 5.
No.
Is this part of the solution?
Yes.
Uh-huh. All right, so we had 5 here. Let's say we had 10 out here. Okay, so we have 10 over here. 10 greater than -6.
Yes. And greater than 5. So it works.
And 10 is greater than 5. So it's an OR situation. So how much gets shaded?
All of it.
All of it. Now, let's take this one point here that was also an open dot. That was 5, right? Is 5 greater than 6?
Yes.
Is 5 greater than 5?
No.
Do I plot as part of the solution the true-false?
Yes.
I do on the OR.
Why?
Make sense?
Because it
Because
satisfies
one-
one of them.
What satisfies 1? Okay, so my solution to this problem, rounded bracket at -6, going all the way to infinity.
That's
That's
it?
it.
Wait, so you just get rid of the or?
So then there's not two different answers on
So
this.
because it's
So the OR, a lot of times, if it's like this kind of compound inequality where it's overlapping, you only have one sequence of events. If I go back a few slides, this was the OR. Oh, that's the AND. Oh, I didn't do one of the traditional ORs. So, but this works with the one. The traditional OR, if our graph looked like this, if we graphed it, our solution looked like this. We have, if that's what our graph looks like, we go from -infinity to -6, close dot, or from 3 to infinity. So that's what we had been working on. That's what we had been working on originally. Okay, but now we've kind of made one of these flip over like this problem, where it overlapped. So from here over, at least one of the solutions is true. Could be both of them true. Okay? So that's a bigger concept right there. Is it sometimes confusing?
Yes.
Yes and no. Depends. Depends who you are. Okay? Does it mean you're broken if you're confused? No. You are not broken at all. So your assignment, what I will take a look at tomorrow, a few things. There is an assignment on Schoology. Some of you have worked it.
Wait, do we have to do
Yes, this is due Wednesday night.
What the hell?
Okay, I signed it last week.
Oh. That
Okay.
was it? Oh, okay.
Some of you have done it already, so good for you, for those of you who have done it.
I forgot about
Okay, don't forget about it. I'll remind you tomorrow, and I'll remind you even on Wednesday. Okay, so the chapter 2 practice test. No, it's Tuesday. Does it? Oh, it is Wednesday. Okay, you're right. I did. Is that okay for you? The practice test, which is pages 59 and 60, we're going to, I want to see, I'm going to mark off tomorrow and go over tomorrow. Yeah. And then come tomorrow, I will then, after we go over the practice test, I will give you the take-home version of the test, which you guys, might have some time in class to work on it. But that's what we got going. Cool? Dude, I feel really good about this class. You guys are awesome. If I could, I would say everyone should go get Egg McMuffins and pancakes.
I'm sorry. I should have
Thank you.
I'm sorry.
Maybe
I heard it's free Egg McMuffin Day.
Seriously?
So what we could do
Just go over there going, hey, free Egg McMuffins. What?
since we feel so good about the class, how about we go get like muffins and stuff, but we